Have you ever wondered what is going on inside your students' heads when they are learning? To answer this question, we need to understand memory. There are two types of memory, long-term memory and short-term or working memory. Learning is a process of taking new information in working memory and storing it in long-term memory. We do this by retrieving knowledge in long-term memory and working with it in short-term memory before bringing it back to long-term memory. Let's use technology as an example. You can think of long-term memory as a network of servers where individual nodes of information are connected and stored. Cognitive science calls these schemas. You can think of working memory as browsing the internet. In this example, you are retrieving files like HTML and graphics from long-term memory to view websites in your browser in working memory. Sometimes we save information when we're online, such as sending an email or shopping. Our information is processed by the browser and sent in a new format to servers or long-term memory. Just like learning, browsing the internet is like retrieving schemas of data to use them in short-term memory and reconsolidating them back into long-term memory. There is potentially unlimited space in our long-term memory, but there is a finite amount of space in our working memory. So what happens when you overload it? If we're talking about surfing the internet, your computer may slow down or crash. But what happens in our minds can be addressed with cognitive load theory. Cognitive load theory takes this notion of the schemas that move from long-term memory to working memory and back, and says that as we're presented new information, we're taking that data and forming new schemas. So if we have too much information thrown at us in a complex and confusing way, we can easily get overloaded. When we learn, we are taking the nodes of information in short-term working memory and reconsolidating them into a more complex and connected schema of knowledge. This is why it's so much easier to learn when you're already familiar with the content than when everything is brand new. So how do we do this? We know that working memory has a limited and specific size. Think of it like a measuring cup. There is only so much you can fit inside. Depending on the task that you are trying to learn or the concept, more complex things are going to take up more room in your cup. For example, trying to learn to play the piano would take up much more room in your cup than if you were trying to learn to play the triangle. This is called intrinsic cognitive load. The size of this cannot be changed. Taking these bits of information and forming and automating new schema, which are complex and mature, is what's happening in your mind while you are learning. That's called germane cognitive load. What we're left with is anything that might be distracting or confusing or otherwise interrupt this process. That's called extraneous cognitive load. The intrinsic load cannot be changed, but if we are able to minimize the amount of extraneous load, we're left with more room for the germane cognitive load, thus making for a more efficient and effective learning experience. What can you do to decrease the extraneous cognitive load on your learners and improve the learning experience? The answer, essentially, is anything that will help your learners to construct and automate schemas. For example, activating prior knowledge and chunking content helps to add new information to an existing schema. Let me give you an example. Look at these 12 letters: P, A, V, R, W, E, U, B, T, L, C, O. Now close your eyes and recite them back to me. How'd you do? Let's try it again, but this time I will activate your prior knowledge and chunk the information. Ready? UMS, IBM, ESL, USA. Now close your eyes and recite them back to me. That was much easier, wasn't it? If you try to recall the first string of letters tomorrow, you probably will have a difficult time. But if I ask you to recall the second set of letters, you will likely remember most of them. Some strategies for automating schemas are to use repetition and apply knowledge in new ways. Set your course up with a familiar structure so that students always know what to expect and where to find content without having to expend much mental energy. When students learn a new concept, ask them to apply it in a new situation. When they learn a new skill, give them plenty of practice. These are just some of the strategies you can use to reduce the extraneous cognitive load on your learners. If you would like additional support, contact an instructional designer at University College.